So we have 8318 here. It says a simple random sample of 10 pages from the Merriam-Webster's Collegiate Dictionary is obtained, and the number of words defined on those pages is found with these results. So they're nice enough here to go ahead and give these to us in symbolic form there. So sample size of 10, sample mean of 53.3, sample standard deviation of 15.7. Given that this dictionary has 1,459 pages with defined words, the claim that there are more than 70,000 defined words is equivalent to the claim that the mean number of words per page is greater than 48 words. Assume a normally distributed population, use a 0.01 significance level to test the claim that the mean number of words per page is greater than 48 words. What does the result suggest about the claim that there are more than 70,000 defined words? So what we want first is our claim here that they want us to test. And our claim here is that the mean number of words per page is greater than 48.0. If you take the 70,000 and divide it by the 1,459 pages, that's where the 48 is coming from, in case you're wondering. The opposite or negation of this claim is that mu, the population mean, is less than or equal to 48 words per page. And now we're ready to set up both our null hypothesis and our alternate hypothesis. If it's mu in the claim, it's mu in the hypothesis statement. If it's 48 in the claim, it's 48 in the hypothesis statement. And then in between them in the null, it's equals, because it's always equals between them in the null. And in the alternate, it's the strict inequality, which in this case is the greater than. And our little bit extra here for setting up the conclusion with respect to the claim, we put in the R and the S, and then we wonder which one is most like, if not identical, to the claim, and that is the S there. So down, when we get to step F, we're going to talk about whether or not we support the claim that the mean number of words per page is greater than 48. So now we can identify the pieces. The tail of the test, we look at the strict inequality that's pointing to the right. So this is a right tail. Alpha is our significance level. That's 0.01. And again, they were really nice to us in identifying in symbolic form our sample statistics. Now our sample mean is greater than 48, but the question is it significantly greater? And does it seem like that to us? Doesn't really matter. We need to know what's the likelihood. And a lot of the likelihood is going to be dependent on standard deviation there. There is one more thing that we needed in this question because the sample size was only 10. They told us that our population was normally distributed. That's what made it okay with the sample size that wasn't greater than 30. So there's one last thing we need to do before we go to statdisk, and that's write our rule of rejection. So we're going to reject null hypothesis if the p-value is less than or equal to 0.01. So our test statistic here, well, statdisk would tell us that it's t if you didn't know already. And then we're also going to need the corresponding p-value there. So at this point, we're ready to go to head on over to statdisk and put in our information. So let me switch our screen here over to statdisk.
Gary, if you like, I can be running these instead. I didn't even think about that. I can run these in statdisk as you're prepping the next one. Oh, never mind. Okay, you've already got it.
I got my cheat sheets ahead of time.
Fair enough.
So our alternate hypothesis, this is why I have you writing down which tail we're testing here. It is a greater than. Our significance level, which was alpha, 0.01. Our claim mean was 48. We don't know what the population standard deviation is here. Our sample size is 10. Our sample mean is 53.3, and our sample standard deviation is 15.7. So if we go ahead and hit evaluate on that, then let's go ahead and hit plot. What we see is our critical value on the graph here is in red, and our test statistic, the blue line for that, is coming in right around 1. It is not off in the tail. Our sample result is just over 1 standard error away, 1 standard deviation away from our claim of 48. We got a result consistent with that. Looking at our p-value, it's 0.1568. So yeah, it's definitely not going to be less than our significance level. So let's take these back over. So our t is 1.068. Our p-value, and I line these up right underneath. And is 0.1568 less than 0.01? No, it is not. So we fail to reject the null hypothesis. And just shrink this down so I can keep everything visible. When we fail to reject, we don't have the evidence. So we have insufficient. Evidence 2. And we circled the S, so it's to support the claim that. And then we just go with exactly what the claim was. The mean number of words per page is greater than 48. So let's read that in its entirety. You know, when we put it together, we're putting it together in 3 separate pieces. Don't forget to kind of go back, read it all the way through. So we have insufficient evidence. We don't have the evidence to support the claim that the mean number of words per page is greater than 48 words. So our sample result was consistent with a mean of 48 words. That doesn't mean that the true population mean is 48, just means that our result was consistent with it. And when it comes time to making a decision about it, we're going to have to live as if that's our reality here. So what do the results suggest about the claim that there are more than 70,000 defined words? Well, that 70,000 defined words was where the 48 words per page came from. And we're not concluding that it's more than 48 words per page. So we're not concluding that it's more than 70,000 words.
Hey, Gary, I wanted to add something briefly, but after you ask people for questions. But before I do that, will you flip back to your statdisk screen for a second, in particular to the plot?
I will do that in just 1 second. I want to just point out one
Yes,
thing.
definitely, definitely.
One of the things you'll always see in the language is you won't see that this proves this, or it's, there's with absolute certainty that this is the case. The phrasing that you will see is, based, it would appear, it would seem that they're putting caution into their phrasing because we're not working with absolute certainty. So I will go back. There you go.
So take a look at Gary's plot there of the hypothesis test with, it says hypothesis test 1 mean student t-distribution. It took me, like, I'm not gonna lie to you, a few years teaching this stats class before this really drove home to me what we're looking at in this plot here. There's a lot of information encoded in that picture, and I wanna grab the screen just for a second and remind you of that. Now, Gary may have gone over this in his class. I know I never got the opportunity to do so. Yeah, I'm gonna take your screen over, it's okay. So if I take this screen over, I'll move these off of here. You're looking at a zoomed in version of the plot that Gary just had up. So this blue line we said was the test statistic, and the red line was representative of the critical value in this situation. Yeah? Gary, with me?
Yes.
So the p-value that you find in these problems is the area in the tail of the test beyond the value of the test statistic. So what was the p-value in this question?
Just shy of 16%.
So a p-value here roughly is 0.16 or so. Alpha in picture form is here, and this was a 0.01.
Correct.
So alpha is this red area, and this p-value is this blue area that I've shaded in. We reject the null hypothesis when what? P is low, null must go. So if the p-value is lower than the value of our significance levels, when we reject the null hypothesis. Think about what that means in terms of the areas encoded in this picture. If the p-value is less than or equal to the significance level, what that means is this test statistic has to live beyond the critical value so that the area to its right in a right-tailed test would be less than the area represented by alpha. I realize it's a minor point, but it's something that I have always found really helpful once I realized it, to remind me of what that rule of rejection is really telling us about. Kind of nuts and bolts of it anyways. And that this, if you know any kind of calculus, this makes good sense to me because I'm a calculus person. But you might find that helpful when trying to remember the rule of rejection. Alpha is the area beyond the critical value depending upon the test, and it could be in one tail and it could be in two tails if it's a two-tailed test. But the p-value is the area beyond the test statistic in those cases as well. Now, feel free to correct me if I said something or if I misspoke there, Gary, but that is something I like to kind of bring up and point out in my classes that I just never had the opportunity to do.
Nope, you were good.
All right, so any questions on that? All right, back to you, Gary.
Yeah, I'm gonna take that over so I can